Greetings, this is Mr. Caslin. In this video we're going to verify that one function is the inverse of another function. In a previous video we took the original function, we found its inverse, and then I said, well, we can verify that these are inverses, kind of do a check step. That takes a little work in this case, so I'd create a separate video out of it. So here it is. Now remember, we have f of x is the name of one function, g of x, we suspect this is the inverse of the other function. So we could call this f of -1 of x, basically the inverse of this function. Okay, now there's a math property you may or may not realize that if you do a composite function, meaning if you take the inverse function and you stuff it inside of the original function, if it's truly the inverse, then that's going to equal x. Okay, if you take the inverse function, you do a composite function, which means stuff it inside of the original function, that should simplify to x. So with a rational function, these rational functions that have variables in the fractions, it takes a little bit of work. So we'll have to use some fraction math here to prove that this function here is the inverse of this function. Okay, so the first thing we have to do is take our inverse function, 2x plus 1 over x minus 1, and stuff it inside of this function. What that means is substitute or replace the function everywhere you have x in your original function. Okay, so that means take 2x plus 1 over x minus 1. Okay, we just replaced that x, and we still have the plus 1 in our numerator. Now, replace that function with this x also. So you have 2x plus 1 over x minus 1 minus 2. All right, so all we did was take our inverse function and stuff it inside of our original function. All right, yikes, we have these complex fractions here. If you're not good in fraction math, you want to pay close attention to what to do next. All right, what I would do is you need some common denominators to add these terms together, and we need common denominators to add those terms together. So let's give that a try. Okay, let's try our numerator first. Okay, we have 2x plus 1 over x minus 1. And we're going to add 1. Well, how do we add 1 so that it's a common denominator of x minus 1? Well, anything divided by itself is just 1. So think of that as x minus 1 over x minus 1. Okay, down here in the denominator, let's do the denominator in blue. Okay, we have 2x plus 1. Man, I'm still not very good at writing with a mouse. Hopefully someday I'll get a great writing device. Okay, so I already replaced x with the inverse function. I'm trying to simplify this. I'm going to have 2 times one, so I'm going to treat 1 as x minus 1 over x minus 1. So 1 times 2 would be this 2 here, and we have common denominators. Okay, so now we can add the fractions in the numerator. Let's subtract this fraction from this fraction in the denominator. See what we get. Okay, so up here we have basically 2x plus x, which is 3x. That took care of that and that. And then we have positive 1 plus negative 1, which is 0. Those cancel. I end up with 3x over x minus 1. Okay, still haven't gotten rid of all our fractions yet. Over here we have 2x minus 2x. I'm going to distribute this 2. I'm going to get 2x minus 2x. So those will cancel. Now here I have a 1 minus negative 1. Oh, excuse me, we're distributing. Oh, here's what you got to watch out for, and I almost fell into that trap. Make sure you distribute that 2. You have 1 minus 2 times negative 1 which is 1 minus positive 2, which is 1 plus 2, which is 3. Okay, so what we did was we distributed, when we distribute that negative 2, it becomes negative 2x plus 2. Okay, so the 1 plus 2 becomes 3. All over the common denominator, which is x minus 1. Clean this up a little bit. Okay, now we have a fraction divided by a fraction. I don't know about you, what your math teacher does, but I do what's called keep, change, flip. If you have a fraction divided by a fraction, keep the first fraction, change your division to a multiplication, and flip the second fraction. Get the reciprocal of that second fraction. Okay, I call that keep, change, flip. All right, now when you multiply, you can either multiply these across, or because it's multiplication, you can cross cancel. The x minus 1s and x minus 1s will cancel because they're factors of both the numerator and denominator. So we're left with 3x over 3. Well, 3 is a factor of the numerator and denominator. So it turns out that when we simplify this great big complex fraction, we get x. So it's true that we found this function to be the inverse of that function. We did a check. We simplified all the fractions. So f of negative 1 of x is just x. Okay? So we'll write that one more time. F of the inverse of x, the inverse, excuse me, of f of x is equal to x. So we have a math property that tells us that this function is the inverse of that function. All right, hope that helps. It may take, because of all the fraction math, it may take you to watch this video a couple times. We'll see you next time.